All right, we are back with video lecture 14. Shifting gears a little bit, but we're still using our property of exponents to be able to do the things that we're about to do. Today's video lecture 14 and 2 videos within it, we're largely talking about using a distributive property. So we're going to be multiplying with these things called polynomials. So you're going to be looking for stuff like multiplying a polynomial within your homework, lots of topics in relation to this, okay? But first, I want to bring your attention to the fact that we've actually already considered polynomials without naming those. So a polynomial, it's a single term or a sum of terms in the form of a times x to the nth power, where a is a coefficient, x is our variable, and then n is going to be some non-negative integer, so some whole number there. So actually, when we were doing lines, right, we wrote mx plus b. So a line, if I wrote 3x plus 7, that is actually a polynomial because it takes this form, right? It has a 3 as a coefficient, x to the first power, and then this 7, it's a constant term. It's a coefficient, it's quote unquote a coefficient of 7, and then it has x to the 0 as its 0 as the power of x there. A couple of other things about polynomials. Polynomials are named by what's called their degree, and the degree comes from the highest power present on the variable. So in this case, a line, what's the highest power? What's the highest power on the variable here? We have a 1, right? We have a 1, so this would be a degree of 1. Additionally, we kind of talk about polynomials in terms of how many terms they have, how many pieces make up this polynomial. This piece, or this polynomial, is made up of 2 pieces. So we would call this a binomial. Something that's a single piece. So if it was just 3x, we would have a monomial. And then the last one we'll talk about is if you were to happen to see something like this in the future. Spoiler alert. Remember, our degree is named by whatever our highest power is. So in this one, our highest power is a 2. So this would be a degree of 2, or a second degree polynomial. And this one has 3 pieces. So what do you think it's named in terms of its terms? It's a trinomial. So we'll see more stuff here later about that. But just making sure that when your instructor says polynomial, you're kind of understanding what that is. When we say monomial, binomial, trinomial, that'd be great too, okay? So the polynomials I showed you here have a single variable, just x. But as you can see above, we can have polynomials that have multiple variables within them, okay? So the first thing we're going to talk about is how can we multiply polynomials, especially if they have maybe different variables, okay? So let's start out with the first one. The first one just has a single variable. We just have z's. So first thing I want to ask you is this thing out front, in relation to its terms, how many terms is that? 1 term, right? 5z squared. So we would call this a monomial. And then inside the parentheses, we have 2 terms. We have 2 pieces. We would call that a binomial. So we are doing a monomial times a binomial. We're going to just use our distribution, right? This multiplication. So we are going to take this whole monomial and we're going to distribute it to the first piece of this binomial, and then we're going to distribute to the second piece, okay? So let's say one spot at a time. We got a couple of numbers here that we're multiplying together. We got 5 times 9. So we get 45. And then we've got z squared times z to the third. It's a product. So our product property for our exponents means we get to add. So we're going to get z to the 5th. Okay. So that's distributed the first term. Should have used the green still, but that's all right. All right. Let's distribute to the -7 now. So 5 times -7, -35. And then z squared, there's no other z to combine that with, so we're just going to make sure that it comes along for the ride. All right, so now we got 45z to the fifth minus 35z squared. Can we combine these things? No, they are not like terms. In order to combine, the bases have to have the same power on them, right? Right. Back when we were doing the exponent properties, we didn't combine things that have different bases, but we also have to have the same power on the bases to be able to combine them into a single one. So this is a good final answer. Okay. All right, let's move on to the next one. We again have a monomial times a binomial. We got two separate pieces separated by a subtraction sign. All right, distributing. We got negative 2x to the third, and we're going to multiply it by negative 3x. So numbers, coefficients, we got negative 2 times negative 3, we get a 6. X to the third times x to the first. X to the fourth. Keep moving. Distribute it to the second term. Negative times a negative again is a positive, and it's going to be a positive 8. And then x to the third, there's no other x over there. And then there's also a y over there. Those things don't go together into a single piece, so we just need to write those two pieces that we have. We're going to get x to the third y. All right, again, these two terms will not combine because they're not like terms. They don't have exactly the same variables or the exponents on those variables, okay? So this is a final answer. All right, got one more. Let's name this thing out front, negative 2w x to the fourth. This is all kind of like, it's all one multiplication piece. So this is a monomial, it's one piece. And then inside our parentheses, we have 1, 2, 3 different terms. So we're taking a monomial times a trinomial. Let's wrap up this monomial. Let's distribute it to the first term of our trinomial. So coefficients, negative 2 and 3, we get negative 6. In my monomial here, I have a w, so I've got w times w squared. Gives me w to the third. And then I had an x to the fourth in that monomial, so that I need to make sure I'm bringing that along for the ride. There's nothing to combine it with, but I still need to keep writing it. All right, so that's the first term. Second term, we've got negative 2 times a 4, so negative 8. A w times a w to the third, so w to the fourth. And then we have x to the fourth times x to the first, so x to the fifth. Great job, keep on moving. Times the last term, so negative 2 times negative 6 gives me positive 12. The w this time has nothing to combine it with, so we just write it. And then we got x to the fourth times x squared, x to the sixth, we get to add, okay? None of these are like terms, so this is the final answer. All right, great job. That's all I got today. Please go and try out some stuff in your homework. We're looking for multiplying polynomials, all right? Great job. I'll see you back for one more video for video lecture 14. Take care.